Welcome dear friends again to my channel Geotechnical Engineering Consultancy Tips. This lecture is actually on the black cotton soils. This is a very heated and known topic in soil engineering, soil mechanics, rather to say geotechnical engineering, because in India many states, many cities of many states have these kinds of soils present on which building, construction and road construction is a kind of a little bit difficulty. So friends, actually this lecture is being numbered as 12, although this is 15th in this series of mine. It will be a little bit shorter lecture because I will be covering black cotton soils in two parts. Number one is black cotton soils and its detrimental effects, and the next lecture will be on and about the preventive measures for the foundation of buildings to be constructed on such kind of soils, and how to take remedial measures, which kind of remedial measures for constructing the roads on these kinds of soils. So coming over to my current lecture, as per section 2 structural design, part 6 soils and foundations of National Building Code, the black cotton soils have been defined as that these are inorganic clays which are Montmorillonic in structure. This is a kind of a structure जिसमें when we discuss about the composition of the soil particles and its arrangement, this is what is referred to as, in the case of black cotton soils, this is defined likewise because of its organizational structure, the way the particles of black cotton soils are arranged. This is basically yellowish black or blackish grey in color. In most of the cases, rather to say predominantly, and have been found in Uttar Pradesh, Madhya Pradesh, Maharashtra and Andhra Pradesh in India, and some other states also. But these are four major states where we usually do encounter black cotton soils. What is actually the major property of black cotton soils? It has swelling and shrinkage properties which naturally come to the fore on any seasonal moisture variation beneath the ground, or rather to say, whenever these soils come in contact with water, these soils swells. That is, they create an upward thrust, they impose upward pressure on the soil, and whenever the water content reduces in these soils, they dry up and then they shrink and become too hard. When we do investigate any boreholes vertically into these kind of soils, the standard penetration test values come out to be in the range of 50s or 60s or 70s, or may even come to 80s. Any hard steel rod can bend into this if it is dry, if it is in dry condition, and if it is soil, if it is in soft condition, it is very loose soil. Rather to say, it describes about the large volume changes due to any small percentage of water content change in these kinds of soils. How are these usually identified? Is the liquid limit of these kind of soils usually varies from 53 to 92%. Its plasticity index may vary from 16 to 54%. These are all based on the cumulative data being gathered for many years. It may vary a little bit, 1 or 2, 3, 4 percentage points here and there, but is usually the case. That is why I am mentioning it out here. its shrinkage value varies from 7 to 18%. And what actually these kinds of soils contain in predominance is it contains silica, alumina and iron. And the range of silica may vary from 40 to 45%. The range of alumina content in this can vary from 14 to 22%. What usually happens is you have to check the differential free swell and the swelling pressure in these kinds of soils, and based on the differential free swell content, its range of expansiveness is defined as low, moderate, high and very high. Say if the differential free swell is less than 20%, its range of expansiveness is described as low. If DFS is in between 20 to 35%, its range of expansiveness is defined as moderate. And if it is in between 35 to 50% this DFS, its range of expansiveness is defined as high. And if it is greater than 50%, its range of expansiveness is defined as very high. Now, what are its detrimental effects on foundation and on pavements? On foundation of lightly loaded buildings, what actually happens is due to seasonal moisture variations and alternative cycles of swelling and shrinkage, the foundation may differentially settle. Means the foundation beneath the wall on one side may settle a little bit more than the other side, which may result in causing of wide cracks in the wall, and in turn your roof slab may leave your wall and the structure may not look good to your eyes where you are living in it. And desiccation also may occur. Rather to say, in these kind of soils, alternate foundation methods need be explored, which I will be mentioning in my next lecture in reference to black cotton soils. And what happens in roads? In roads, the subsidence occurs. The roads becomes uneven. The road surface becomes undulating. So in these very cases also we need to apply some remedial measures on how to build these roads, which I will be referring to and discussing with you people in my next lecture. Now at this very juncture I will say that I am finishing off this lecture of mine. Hope you will like this lecture of mine, because it is the most sought after subject in soil engineering, where people like to know about black cotton soils. And I request dear fellows and friends to kindly subscribe to my channel and shower your love towards my channel. Thank you very much.